Alright, Assalamualaikum and a very good morning everyone. So today I'm going to teach you guys about hybridization. Okay, so today we're going to look at unit 4.3 Orbital Overlap and Hybridization. So the learning outcomes that you inshallah will get after this tutorial class is first you will be able to draw and describe the formation of sigma and pi bonds from the overlapping of orbitals, and B, describe the formation of hybrid orbitals of a central atom. There are 5, which are sp, sp2, sp3, sp3d and sp3d2 hybridized orbitals using the appropriate examples. And then lastly, you will be able to illustrate or draw the hybridization of the central atom and the overlapping of orbitals in the molecules. So there are a few parts of tutorial session in this tutorial session. So we are going to get started. Alright, so first we are going to look at what's the difference between the Vesper theory and the valence bond theory, which we will learn here. So valence bond theory is the theory that we are going to use for this subtopic, hybridization and orbital overlapping. So the previous subtopic, which is molecular geometry and bond polarity, we use the Vesper theory. So what's the difference between Vesper theory and valence bond theory? So Vesper theory, it's used to predict the molecular shape. Alright. So Vesper theory is used to predict the molecular shape by assuming the electron groups which they tend to minimize the repulsion. So Vesper theory, they only explain the orientation of electron groups. Alright, they are not explaining the formation of how the bonding form in the molecule. So that is why we use this valence bond theory. This valence bond theory to explain the interaction of atomic orbital, which is orbital overlap, that create the covalent bond, the formation of bonding in the molecule. This valence bond theory also will explain how the molecular shape are rationalized by this interaction. So what is orbital overlap? So orbital overlap is the formation of covalent bond which is caused by the orbital overlapping. So how does the orbital overlapping occur? So when two atomic orbitals, they interact with each other, each of the atomic orbital will then contribute one unpaired electron to another atomic orbital for them to form a sigma bond or a covalent bond. Okay, so this orbital overlapping will cause the formation of sigma covalent bond here. So for example, one unpaired electron from one s orbital will share one electron with one 2p atomic orbital. Okay, so there are two types of bond that we are going to learn. The first are sigma bond and the second are pi bond. So sigma bond is this symbol and the pi bond is this one. Okay, so let's go into deeper on on how the sigma bond and pi bond are formed in the molecule. Okay, so first let's see the formation of sigma bond. So sigma bond, it consists of all single bonds. So all single bonds, we call it sigma bond. And the sigma bond is formed from the end-to-end overlapping of atomic orbitals, end to end. Okay, from dia punya buntut to dia punya buntut. Okay, buntut sorry, dia punya hujung-hujung atomic orbital. Okay, for example, okay, there are three types of there are three ways on how this sigma bond are formed. let's look at the first way. So the first one is between two s orbitals. So the first one is between two s orbital. So for example, hydrogen gas. So first we need to state what is the electronic configuration. So as we know, hydrogen is 1s1, and when we do the orbital diagram, this is how it looks like. So it has one unpaired electron. So when two hydrogen meet each other on the way, okay, they will tend to overlap to form hydrogen gas. So since this hydrogen has one unpaired electron and this hydrogen has one unpaired electron, they will form a covalent bond through the orbital overlapping to form a sigma covalent bond between two hydrogen atoms. So now they have one sigma bond. Okay, so hydrogen gas form one sigma bond. Okay, all right. Next, the second way to form the sigma bond is between s and p orbitals. Okay, so the end of the 2p orbital will overlap with one s orbital. So for example, HF molecule. So first we need to state the orbital diagram for hydrogen and fluorine. So hydrogen, they got one unpaired orbital in one s atomic orbital, and for fluorine, they got one unpaired electron in 2p orbital. So one unpaired electron from one s orbital of hydrogen atom will overlap end to end with one 2p fluorine atom. So they will form one sigma bond where each of them share one unpaired electron to form the sigma bond. Okay, lastly, the last way to form the sigma bond is between two p orbitals, where they will form through end-to-end overlapping like this. Okay, dia punya end of 2p fluorine orbital will overlap with the another end of another 2pf fluorine 2p orbital. Okay, so they will form sigma bond. Okay, now we have learned that to form sigma bond there are three ways. And the first way is the overlapping between two s orbital, the end-to-end overlapping between one s and one p orbitals, and the end-to-end overlapping of two p orbitals. Okay, so now we are going to look at how the formation of pi bond is formed. Okay, so for pi bond it contains in multiple bonds. So multiple bond consists of double bond and also triple bond. So double bond contains one sigma bond and one pi bond, and triple bond consists of one sigma bond and two pi bond. Okay, so just now the sigma bond is formed by the end-to-end overlapping of atomic orbitals. So pi bond in this case, it formed by the side-by-side or side-way overlapping of atomic orbitals, side by side. Okay, not end-to-end. This is end-to-end, this is side-by-side. Okay, alright, so we are going to look at two different examples of the formation of pi bond. So first we look at how the formation of double bond, in this case oxygen gas for example, is formed. Okay, so let's look at the first example. So we got the example for oxygen gas. So first we need to draw the Lewis structure first. So this is the Lewis structure for the oxygen gas. Next, we need to come out with the orbital diagram of the oxygen. So there are 1s2, 2s2 and 2p4. So in this case, we see that there are two unpaired orbitals. So we know that double bond consists of one sigma and one pi bond. So that means that this one of these unpaired electron will be used to form sigma bond, and the other unpaired electron will be used to form pi bond. So just now we said that the sigma bond is formed through the end-to-end overlapping, right? So oxygen is a the unpaired electron is in 2p orbital. So we draw the 2p orbital. So this is the 2p orbital. Side by end-to-end overlapping will form sigma bond. And the other 2p orbital here is used to form a side-by-side overlapping to form the pi bond. So one sigma bond through the end-to-end overlapping, and one pi bond is formed by the side-by-side overlapping. Okay? Alright, so for the explanation, we can explain that one valence electron in 2p orbital of two oxygen atom is overlapped to form sigma bond, and one valence electron in 2p orbital of two oxygen atom is overlapped to form pi bond. Okay? Alright, understood? Alright, good. So now we are going to look at the second example. So the second example is for triple bond. How we form triple bond. So as we know, triple bond consists of one sigma bond and two pi bond. So let's look at the nitrogen gas example. So first we need to draw the Lewis structure for the nitrogen gas. So this is the Lewis structure. We got one sigma bond here and two pi bond here. Okay, so next we state the electronic configuration using the orbital diagram. So there are 1s2, 2s2 and 2p3. So there are three unpaired electrons. So we are going to use this for sigma and this for formation of 2 pi bond in nitrogen gas. So this, oops, I forgot to do this. Okay. So since we know that the sigma bond is formed by the end-to-end overlapping, so one of the 2p orbital is arranged, is drawn using the end-to-end barring. Okay, macam baringkan dia. Okay, so that it can overlap end-to-end to form a sigma bond. And then the other one, this 2p and this 2p, okay, make sure that when you want to do the side-by-side or sideway overlapping, make sure that the orientation of the p orbital is the same. Okay, if the p orbital is drawn horizontally, then is drawn like what we call it vertically, I'm sorry, then both must be vertical. If it's like diagonal, then both must be diagonal so that both can form the side to side to form a pi bond. Okay, so in this case, this two is the vertical 2p orbital and has the same orientation. So these two will form pi bond. So each will contribute one valence electron and one valence electron to form one pi bond. And this one, the Sanyet one here, they will form another pi bond, so each will contribute one unpaired electron to form pi bond. So here nitrogen gas, so here one valence electron in both nitrogen in both 2p orbital of nitrogen atom will form sigma bond, and two valence electron from both 2p orbital of nitrogen atom will form 2 pi bond. So this is how the overlapping in nitrogen gas and oxygen gas is formed. Okay? Alright. Are you clear? Alright, good. So now we have learned, we have discussed on how the sigma bond and the pi bond is formed in the molecule. So now we are going to look at what is hybridization. Okay, so just now it's just the mukaddimah, the what we call it permulaan, the pengenalan. Okay, so now we are going to look at the hybridization. Okay, this is like one of the mains, the highlight of the chapter 4 chemical bonding, which I really love. This one I really love. Okay, I really love this topic. So it's quite hard, but after multiple tons of exercise, you will be fine. Okay. All right. So what is hybridization? So hybridization is a process of mixing atomic orbitals in an atom to form a new set of hybrid orbitals. So they mix, for example, S and P and D, they mix all the atomic orbitals in the atom to form a new set of hybrid orbitals. And usually, the only atom that took part in this hybridization is the central atom. All right, usually it's the central atom. Okay, so what is hybrid orbitals then? So hybrid orbitals is the orbitals formed from the mixing of pure atomic orbitals. Okay, so as you guys know, there are 5 types of hybridization that we are going to learn in this chapter. The first one is sp hybridization. The second one is sp2 hybridization. The next one is sp3 hybridization, sp3d hybridization, and sp3d2 hybridization. And we are going to look at all this one by one. Okay, we are not going to miss this. All right. So now first let's look at how the sp hybridization form. Okay, so first, sp hybridization is the mixing of one s orbital and one p orbital. So one s orbital plus one p orbital will form 2 sp orbitals. Okay, will form 2 sp orbitals. And the hybrid orbitals will have the shape of linear with the bond angle of 180 degree. So let's look at 2 examples of the formation of sp hybridization. I have done a bit on this and we are going to do the next one together. This one I have done it first so that it can save time. Alright, so now let's look at the first molecule. So we got BeH2. So the first step, we need to draw the Lewis structure of the molecule. So in this case, I have drawn BeH2. So when we look at this molecule, we need to focus on beryllium, central atom. Focus on central atom. So look at central atom. How many electron groups attached to it? 2. Which is the bonding electron, the bonding pair. Okay, and then we look at the electron group arrangement. According to Vesper theory, the electron group arrangement is linear, and the molecular shape is linear because it's linear, memang linear je, tak ada lain. Okay, and then we state the electronic configuration for beryllium is 1s2, 2s2. Okay, and then we move on to the central atom. We want to focus on the valence electron. So when we the hybridization process will be described in 3 states. Okay, this is only for central atom. So the first one is the beryllium atom at the ground state. So at the ground state, beryllium only has 2s2, 2p no. Okay, tak ada isi. Okay, however, when we look at the beryllium central atom, beryllium need to form 2 covalent bonds. So to form 2 covalent bonds, beryllium needs 2 unpaired electrons so that it can overlap with another molecule to form a sigma covalent bond. So how can we have the 2 unpaired electrons? So that's when we move on to the second state, which is the excited state. This is the promotion of electron, where one electron from the 2s atomic orbital of beryllium is excited to the empty 2p orbital of the beryllium atom. So these 2 unpaired electrons will then mix together. So one 2s orbital and one 2p orbital of beryllium atom will then mix together to form this sp hybrid orbitals. So at hybridized state, there is 2 sp hybrid orbitals and 2 empty 2p orbitals. So when we draw the orbital overlapping, we draw it like this. So since sp hybrid orbitals is in linear shape, so we draw it in linear like this and label it sp because it one sp and one sp. We got two sp hybrid orbitals here, and each sp hybrid orbitals has one unpaired electron. Okay, and then look at the Lewis structure. Beryllium needs to form a sigma bond with hydrogen atom, and hydrogen is 1s orbital. It got one unpaired electron in 1s orbital. So we draw the overlapping with 1s. So the 1sp orbital of Be atom overlap with 1s orbital of H atom to form a sigma bond. Or when the question asks you to explain the orbital overlapping, you can just say that the formation of sigma bond is formed by the orbital overlapping of one sp hybridized orbital of Be atom and one 1s orbital of hydrogen atom, just like that, as easy as that. And then after you draw it, you put a sigma symbol to indicate that this is a single covalent bond formed between the beryllium and hydrogen atom. Okay, understood? Alright, so now let's move on to the C2H2. So this one, it contains multiple bond, or we call it triple bond here. So triple bond, we got So triple bond, we got one sigma bond and two pi bond. Okay, so we need to do for each. So each carbon will undergo hybridization. So each carbon, the electron group is 2. The electron group arrangement and the molecular shape according to Vesper theory is linear. And the electronic configuration is 1s2, 2s2 and 2p2. So now, around the central atom for both C, but they are the same, right? So we just do one lah, okay? So at ground state, the carbon has 2s2 and 2p2. It got two, what we call it? Two unpaired electron. But here, look at the C one. C needs to have 1, 2, 3, 4 unpaired electrons since each carbon form 4 bond. Kan, ada one sigma CC and one sigma CH and then 2 pi bond CC, betul. So we need 4 unpaired electron. So how? So 1 2s orbital will then voluntarily excite its one electron to the empty 2p orbital. So at excited state there will be 4 unpaired electron. But to form sp hybridized orbital for carbon, we just need 2 sp orbitals. So that means we just need one s orbital and one 2p orbital. So how? So just take these two. Okay, these two are going to be the sp hybrid orbital. So remember that the hybridized orbital will only be used to form a sigma bond. So how can we form the pi bond then? So the pi bond then will be using the unhybridized orbital. The unhybridized orbital, in this case, unhybridized 2p orbital will be formed to form 2 pi bond between the carbon atom. Okay, so now let's see how it goes like this. Okay, first we draw the sp hybridized orbital for each carbon. So we know that the end-to-end overlapping of the sp orbital of carbon atom will form a sigma bond. So here is a sigma bond. Okay, and then the sp from the other side will form a sigma bond with one s hydrogen atom to form another sigma bond, and here as well. Okay. So now we are going to look at how the pi bond is formed. So pi bond is formed by the side-by-side overlapping, and it need to have the same orientation for it to form the side-by-side overlapping, or else it will not happen. Okay, so in this case, there are 2 unhybridized orbital for each carbon. So we are going to draw each of them, for each carbon, one must be vertically drawn and the second one must be diagonally drawn here. So this one also. Okay, so this each has one unpaired electron here. So this one has the same orientation as this one, so they will form the pi bond. They will each contribute one electron and form pi bond. And the diagonal one, they will each overlap side by side to form another pi bond. So there are two pi bonds here. Okay, so it's very clear now. So I hope that you really understand how the basic concept on how we want to explain the hybridization process for each molecule after this. So now we are going to look at the second type of hybridization, in this case sp2 hybridization. Okay, sp2 hybridization is the mixing of one s orbital and two p orbital to form three sp2 orbitals. So one s orbital plus two p orbital will form three sp2 orbitals. So the shape of these hybrid orbitals is trigonal planar and it has the bond angle of 120 degree. So let's look at the example shown. Okay, we are going to do this together. Okay, all right, so let's see here. First step, we need to draw the Lewis structure. So we got BF3. I have drawn the Lewis structure first because to save time. Okay, so this BF3 here. Okay, let's look at the electron groups around the central atom. So we got 1, 2, 3. 3 electron groups. So according to Vesper, when we got electron groups, 3 electron groups around central atom, then the shape is trigonal planar. Okay, and the molecular shape also, since it doesn't have any lone pair, it has a trigonal planar shape. And this one for boron. So boron has the electronic configuration of 1s2, 2s2, 2p1. Is it? So 1s2, 2s2, 2p1. Okay, now we move on to the second box. We move on to central atom. So we want to focus on central atom because the hybridization process occurs within the central atom. So we need to focus on the valence. So we need to focus on the valence electron. So here, the valence electron is 2s2, 2p1. Okay, when we look at the Lewis structure of the molecule, it has 3 covalent bonds. So that means boron has need to have 3 unpaired electrons so that it can form the bonding with the fluorine molecule, fluorine atom. So how? We need to excite 1 electron from 2s orbital to 2p orbital. So we got so at excited state, the electronic configuration will be like this. This one dari di sini kan, so like this. Okay, now it has 3 unpaired electron. So since the sp2 orbital is 1s plus 1s plus 2p orbital, so we are going to take all these 3 mixed together to form sp2 hybrid orbital. So they will form 3 sp2 hybrid orbitals and 1 empty 2p orbital. Okay, so now we are going to draw the orbital overlap. Okay, so as we know, to draw the we need to draw the central atom punya hybrid orbital. So we know the sp2 hybrid orbital, the shape is trigonal planar. So we need to draw the trigonal planar shape here, here, and here. So this is B. Okay, then we need to label all this, okay? sp2, sp2, sp2. Okay, then we know that so boron dah siap dah lukis dia punya sp2 hybrid orbital. So next we need to draw the fluorine orbital. So fluorine is 2p kan? 2p yang ada unpaired electron. So we draw it. So 2p orbital of fluorine like this. Okay, 2p. So this is 2p fluorine. Okay, this one also 2p, they overlap. Oops. They overlap end to end kan to form the what? Sigma bond with fluorine. Okay, this one also. This one also. Okay, so this is how you label and draw it first. So we can see that one sp2 hybrid orbital of boron atom will overlap with one 2p orbital of fluorine to form a sigma bond. So this one, it will have this electron. Draw this. Okay. Okay. This one also inside the overlapping. This one also. And then you label it sigma. Oops. Sigma, sigma, sigma. Okay, so this is how you draw it. Okay, so for the explanation, you can write it each sp2 hybrid orbital of boron atom overlapped with 2p orbital of atom to form sigma bond. Okay, this is how you explain lah. Okay, alright. Okay, now we are going to move on to this example, C2H4. Okay, so C2H4, so look at the C. So we are going to use both of the C as central atom. So this is multiple central atom case, okay? So, alright, so each carbon, okay, they have 1, 2, 3 electron groups. So that means the electron group arrangement is trigonal planar. The molecular shape is also trigonal planar since there is no lone pair. And the electronic configuration is 1s2, 2s2, 2p2. Okay. 1s2, 2s2, 2p2. So now we are going to focus on the central atom. Okay, the central atom carbon, we focus on the valence electron. So for the valence electron, so 2s2, 2p2. So this is at the ground state. So now we look at the Lewis structure. So how many covalent bonds are there in each carbon? So 1, 2, 3, 4, which means we have 3 sigma bond and 1 pi bond, right? So 4, right? So we need 4 unpaired electron. But now we just have 2. So how? We need to promote 1 electron from 2s orbital into the empty 2p orbital of carbon. So at excited state, it will have 4 unpaired electrons here. Okay. However, for sp2 hybridization, we just need one s orbital and two p orbital to form three sp2 hybridized orbital. So right now we have four. How? Okay, like just now, I just said just now that the pi bond we use unhybridized orbital. So it's necessary to have one unhybridized orbital here so that it can form a pi bond with each other. So now we just need to focus on these three so that it can form three sp2 hybrid orbitals and one unhybridized 2p orbital. And please bear in your mind that the hybrid orbital is used to form sigma bond and the unhybridized orbital is used to form a pi bond. Okay, so now we want to draw. So when we want to draw, then we need to draw the hybridized shape for each carbon. So this is trigonal planar, this is also trigonal planar. Both has sp2 hybridized state. Okay, so let's draw. So excited to draw. Okay, so trigonal planar, since ada one sigma bond between C and C, so we need the end to end overlapping between C as well. So we are going to draw it like this. Okay, trigonal planar for this C and trigonal planar for this C. Okay, so this C also trigonal planar. And then you label this sp2, sp2, sp2. This one also sp2, sp2, sp2. Okay, so carbon here, done. Okay, then when we look at the Lewis structure, each carbon will form two sigma bond dengan hydrogen. So we need to draw the hydrogen part. So hydrogen part here. Okay, 1s hydrogen. And then here 1s hydrogen. Here as well. Okay. 1s hydrogen. 1s hydrogen. Okay, so we have done the formation of sigma bond. Formation of sigma bond between sp2 hybridized orbital of carbon to form sigma bond. Between the sp2 hybridized C and one s orbital of H to form sigma bond. Okay. Okay, so lastly we need to draw the what? The pi bond. So the pi bond we need to have the same orientation. So in this case we just draw the tegak one, the vertical one. So like this. So, unhybridized 2p orbital for this carbon and unhybridized 2p orbital for this carbon. So now each of them have one unpaired electron. They need to do side-to-side overlapping to form a pi bond. Okay? Boleh? Alright. Okay, it will take time for you to understand, but it's okay. We just need to do more and more exercise. Okay. Next, we are going to look at the third one, sp3 hybridization. So sp3 hybridization is the hybridized form by mixing one s orbital and 3p orbitals. Okay, they will form 4 sp3 orbitals. Okay, so the shape for the sp3 orbitals is tetrahedral with bond angle of 109.5 degree. Okay, so let's look at the example. So we got one example here. I got SiCl4. Okay, as we look, I have drawn the Lewis structure. So from the Lewis structure around the central atom, we can see that there are 4 electron groups around them and all is bonding pairs, so no worries. And then that's mean the shape is still the same according to Vesper. Okay, so the electronic configuration for Si is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so we are going to focus on the central atom valence electron. So at ground state, it has 3s2, 3p4. So we have 2 unpaired electrons. But now look at the Lewis structure. Around the central atom, it covalently bonded with 4 chlorine. So that means we need 4 unpaired electrons so that silicon will be able to do an orbital overlap with chlorine atoms. So what we should do? Sorry. Did I miss something here? Oops, sorry. Patutlah. I'm sorry for my mistake. I forgot S yang for Si2, okay? I'm sorry, okay? Alright, so this, okay. So, as we know that we need 4 unpaired electron, betul? So, what we need to do, we need to promote or we need to excite 1 electron from 3s to the empty 3p orbital. So, it will be like this. 1, 2, 3, 4. Okay, there will be 4 unpaired electrons. So, now they can form 4 covalent bond with chlorine. So these 4 will mix together. One 3s orbital will mix with 3 3p orbitals mix together and form 4 sp3 hybrid orbitals. So they are all here together. Okay. So SiCl4. Okay. So now we need to draw the orbital overlapping. So silicon, it will have the hybridized state of sp3 hybrid orbital. So sp3 hybrid orbital has the shape of tetrahedral. So we need to draw it in the shape of tetrahedral. So first silicon 1, 2, 3, 4. This is tetrahedral lah, okay? And then label silicon here. And then label the sp3, sp3, sp3. Oops. 3. Oh, dia tak bagi kerjasama. Okay, wait Okay. sp3, sp3. Okay. I'm sorry, it's quite ugly, but now it's alright. Alright, and then we got fluorine. Fluorine has 2a. Chlorine is 3p orbital. Chlorine. Okay, so draw the 3p orbital for chlorine. So this is 3p for chlorine. Okay. Okay, 3p for chlorine. This one also. I'm sorry, the shape is, kalau you guys lukis, make sure you guys lukis lawa-lawa, draw it nicely. Since I don't have a control with this stylus pen, it's quite hard. I don't know. I mean, if I draw it on paper, it will be this ugly as well. But don't follow my step, okay? Okay, you draw it nicely. Okay, now we need to label the electron and the sigma bond to indicate the formation of covalent bond. So now this will form sigma bond, sigma bond, sigma bond, and sigma bond. So it's crucial for you to label every single thing that you have drawn because each of them carry marks in the examination. So bear in your mind that, okay? Alright, so for explanation, we can explain like this. The formation of sigma bond is formed by the overlapping of one sp3 hybrid orbital of Si atom with one 3p orbital of chlorine atom. Okay, you can do it like that. Alright. Okay, now we move on to sp3 dehybridization. So sp3 dehybridization, okay, is formed by the mixing of one s orbital, three p orbitals, and one d orbital to form 5 sp3d orbitals. 5. Okay, 5. Okay, so this has a shape of trigonal bipyramidal. And the bond angle of 90 degree and 120 degree. Okay, so now let's look at the example. So we have the molecule PF5 here. So I have drawn the Lewis structure. So according to Lewis structure, when we look at around the central atom, it has 5 electron group around it, which means that it has the shape according to Vesper theory, trigonal bipyramidal. Also, since it doesn't have any lone pair, so the molecular shape will take the same as the electron group arrangement, which is trigonal bipyramidal. And the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so we need to focus on the central atom because the hybridization process occurs at central atom. So look at the ground state for the valence electron. It has 3s2 and 3p3. Okay, now look. We need 5 unpaired electrons to find 5 covalent bond between p and f atom. So but now we only have 3. But look, we need sp3d hybridized orbital. So since p is at the period 3 in periodic table, so that means that it has empty d orbital. So it can expand its electron masuk dalam empty d orbital. So now at excited state, one electron from 3s orbital will be excited to the empty 3d orbital here. So at excited state, it will have 1, 2, 3, 4, 5. Okay, since we know that one 3s orbital, one s orbital, 3p orbital, and one d orbital will form 5 sp3d orbital. So all of these will mix together to form 5 sp3d hybrid orbitals at the hybridized state and empty 3d orbitals. So empty tu biar je lah. Okay, so we got 5. Okay, so now we can draw the orbital overlapping. Okay, how to draw? So since we know that the central atom has the sp3d hybrid orbitals, we know that the shape is trigonal bipyramidal. So trigonal bipyramidal has the shape of this. Okay, like this, and then this, and then this. Oh, wow. Interesting shape. Okay, so this label it P, okay, P. And then we label it this sp3d, 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 sp3d. Oh, sayang it. sp3d. Okay, so P has 5 sp3d hybrid orbitals. So we know that they will overlap end to end with fluorine 2p orbitals atom, so that it can form a sigma bond. So fluorine has 2p orbitals, so fluorine Okay, so 2p fluorine, 2p fluorine, 2p fluorine, 2p fluorine, and then last one. Okay, so we have labeled all the orbitals. Okay, so now we need to draw the electrons and the label the sigma bond. Okay, so this from sigma, this one from sigma, this one also from sigma, sigma, and sigma. Okay, so to explain this hybridization, we can say that the formation of sigma bond is formed by the end-to-end overlapping of one sp3d hybrid orbital of p atom with one 2p orbital of fluorine atom. And the molecular geometry is trigonal bipyramidal with the bond angle of 90 degree and 120 degree. A complete answer, full mark. Each level, full mark. Okay, so this is how you answer this question. Alright. Okay, next. Last one, we have sp3d2 hybridization. So sp3d2 hybridization is the mixing of one s orbital, 3p orbitals, and 2d orbitals to form 6 sp3d2 orbitals. And the hybrid orbitals have the shape of octahedral with the bond angle of 90 degree. For example, we have SF6. Okay, SF6. So I have drawn the Lewis structure for you. So the electron groups around the sulfur is 6, which means it has the shape of octahedral according to Vast theory. Since there is no lone pair, so the molecular shape will be the octahedral as well, and the electronic configuration for sulfur is 1 S2 2 S2 2 P6 3 S2 3 P4. Okay, so as you know, the hybridization process is focused on the central atom for now and the valence electron. So we need to focus on the valence electron here. So 3s2 3p4. Okay, as we know, we need 6 unpaired electron to form 6 covalent bond with fluorine. However, we just got 2. So we need to excite 2 electrons to the empty 3d orbitals. We have that because sulfur can expand the orbitals into 3d orbitals since it is in period 3 in the periodic table. So what we can do, one electron from 3s will go to one empty 3d orbital, and one electron from 3p orbital will be excited to the one empty 3d orbital here. So that means we have 1, 2, 3, 4, 5, 6. So since we know that the sp3d is 6 hybrid orbital, so all of these will mix together to form 6 sp3d hybrid orbitals with 3 empty 3d orbital. Okay, so all this hybrid orbital will be used to form a sigma bond with fluorine. So we need to draw it like this. So the shape is like this, and then like this, octahedral, and then like this. Oh, it's quite ugly. Ah, major ugly. I need to draw it. Halala. Okay, and then label kat tengah-tengah ni, labelkan dia S. Tak nak label kat tengah pun boleh label dekat tempat lain sekehatilah. Tapi kalau in this case, I would prefer to label it dekat tengah-tengah here as. Okay, and then we label each of these sp3d2, 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 sp3d2. Kena label lah semua ni. Okay, so make sure lukis tu besar-besar sikit lah. Jangan lukis macam Miss, sebab Miss ni perlukan space yang sangat limited. So I lukis kecil-kecil sikit lah. Okay, so next kita nak buat dia punya fluorine kan. Fluorine 2p kan. So 2p orbital for fluorine. Okay, fluorine 2p label, jangan lupa. Fluorine 2p. Fluorine 2p. Okay. Alright, and last one. Oh, makin buruk. Okay. So we got this. Okay, and then I will label it with sigma and electron. Sigma bawah ni, I akan lukis besar sikit. Miss tak cukup nak lukis ni. So I will draw it here. Okay. Sigma. 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 Okay. Very simple. Okay. So, to explain this, we can explain the formation of sigma bond is by the overlapping, the end-to-end overlapping of one sp3d hybridized orbital of S atom with one 2p orbital of fluorine atom. And the molecular geometry is octahedral with bond angle of 90 degrees. That's it. That's the answer we want. Okay, so I have covered everything in chapter 4.3. I have covered what the bond formed in the molecule. We know we form sigma and pi bond, and I have explained how to form the sigma and pi bond. And on the hybridization part, I have explained there are 5 types of hybridized orbitals, which are sp, sp2, sp3, sp3d, sp3d2 orbitals, and I have explained the step by step on how you want to describe the hybridization process. And for now, the question, the examples that we use is focused on the hybridization of the central atom, not yet the what we call it terminal atom. So that one just a special case lah. But most of the time we only hybridize the central atom only. Okay, so I think that's all for today. I hope that you guys understand what I have teach you for today, and if you have any question, please let me know. Please ask me directly. You can message me via Telegram, or you can WhatsApp me. Any platform can. Okay, so yeah, I am happy to have teach you this topic because this is one of my favorite topic. Okay, so yeah, I will see you guys in the next video. So I hope that you guys enjoy my class for today. Alright, thank you. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh. Okay.